Hi, welcome to Dissolve Chemistry. In the present video, we are going to discuss a very important aspect, that is substitution versus elimination reaction in haloalkanes. Okay, in the previous video, we have discussed various aspects regarding substitution reactions, conditions for nucleophilic substitution reaction, how it is going to follow the SN1 mechanism, SN2 mechanism, all that we have discussed in detail in the previous video. Please, if you want to know more about nucleophilic substitution reaction by SN1 and SN2 mechanism, please go through the previous videos which are already available in the YouTube. Okay. In the present video, we are going to discuss very important aspect, that is substitution versus elimination reaction. Okay. So there is a competition between these two reactions, right? And which is going to achieve at last to give the either eliminated product or substituted product. So that we will try to illustrate in this present video. Okay, so let us start with a simple example we will take first. So that is, you take bromopropane as an example. All right. So in this bromopropane, if you look into CBr bond, it is polar bond. Of course, it is a bond between carbon and bromine. Bromine is more electronegative. So therefore, it is more deviated towards bromo group. And if I disturb this one, generally what type of tendency it has, it will break heterolytically to give, or leaving group will go with the electron pair. Okay, so that much we can assess by looking into the haloalkane. All right. So therefore, when we look into the substrate, we expect that it should go substitution reaction, that to nucleophilic. Means leaving group is nucleophile, means incoming should be nucleophile. So therefore, nucleophilic substitution, it readily undergoes just by looking into the substrate, we can say that one. Apart from this, in the same in presence of the Lewis base or nucleophile, if it is strong enough to abstract the proton, okay, and if your haloalkane contains in the beta on the position of the beta carbon atom a hydrogen atom, if it is there, we call it as beta hydrogen if it is there. Okay, so this we call it as alpha carbon, this is beta. If there are beta hydrogen atoms, so therefore if the nucleophile is strong enough base, if it is, so then what happens, instead of substituting with the bromo group or halo group, so it is going to abstract the proton from the carbon atom, beta carbon atom, and leading to the what, dehydrohalogenation, shifting of that electron. See here how it is going to happen. If this proton is being abstracted, it is going to shift and this bromine will leave readily, and hydrogen, halogen both are eliminated. That is, we call it as what, dehydrohalogenation, leading to the formation of eliminated product, that is alkene we are going to get. Okay, so now how this can be achieved separately, substitution and elimination. Okay, one interesting example and very common example I will take and I will try to illustrate, so that how it is going to differ from one another. Okay, and many times you get confused if it is given in the test or examination, that sometimes aqueous KOH, if it is given, you will be having what, substituted product, and if it is alcoholic KOH, okay, KOH taken in ethanol, say for example, okay, or we call it as what, alcoholic KOH we call. All right. So if you take alcoholic KOH, then the product is your alkene. If it is aqueous KOH, your product is propanol. Okay. So how it is going to differ, even though the reagent is same. Okay. And that difference makes your what, solvent. Here it is water, here it is alcohol. We will see in detail with that. All right. CH3, CH2, CS2OH. The detailed mechanism of this nucleophilic substitution reaction, okay, already I have mentioned that you just go through SN1 and SN2 mechanism, you will get the mechanism of this, right? Now there is a competition between these two, and now what happens, see here, if I use aqueous KOH, we are going to end up with propanol, and if we take alcoholic KOH, it makes a lot of difference, that your product will be propene. Okay, CH double bond CS2. So what is this? This is called propene. All right. Why it so happens? Why I am getting different product? Even though both is potassium hydroxide is the reagent. Okay. So in this case, what happens? Let us see that one. We will just bifurcate this one. Aqueous KOH, if it is there. Okay. KOH dissolved in water. Then what happens? It will ionize to give K plus OH minus aqueous. Okay. As we know that it is a strong base, so therefore it may abstract proton from the water. Okay, OH. So it may abstract proton, right? But leading to what? Again, water and OH minus. Means at the last, you will be ending with hydroxyl ion in water, aqueous. Okay. Now what happens in the alcoholic KOH? When KOH is taken in ethanol, it is polar enough to ionize KOH, ethanol. Then what happens? Your CH3CS2OH. Okay. So with this OH ionized alcoholic, okay, in alcohol. Okay. Now what it does is, it is a weak acid, it is going to act, your ethanol. So therefore, it is a strong base, it has greater capacity to abstract the proton. So therefore, readily it will take up this proton and the resulting will be your ethoxide ion. Okay, and this ethoxide ion is a what? Stronger base than compared to your hydroxyl ion. When it is a stronger base, instead of waiting for bromine to leave and then go and get substituted, what it does, from the beta carbon atom, it will abstract the proton. Okay. So as it abstracts the proton, then leading to the formation of what? Alkene, as you see with the formation of propane here. Okay. So therefore, this is one reason why what happens, this ethoxide ion will abstract the proton. Okay. So we will show like this. This proton is being abstracted, then what happens, bond will shift and simultaneously your bromine will go and HBr is coming out from that. All right. And why? You may ask that why can't it get substituted with bromide ion? See, when you look into this ethoxide, it is little bulkier when compared to your OH minus. Okay. So therefore, to get into this hindered position, it prefers to abstract the proton rather than substituting in that hindered carbon atom. Okay. Because of that reason, what happens? It will abstract the proton and then leading to the eliminated product, that is propene we are going to get. So whereas here KOH minus free ion will be there in the aqueous medium, so therefore it will get substituted with bromide ion. Okay. So nucleophilic substitution will occur leading to propanol, and elimination will occur in presence of ethanol if you take KOH, leading to the formation of propane. So that is how. And one condition you should remember, elimination reaction to occur on haloalkane in beta position, there must be hydrogen atom should be there. Okay. And regarding elimination reaction in detail, we are going to discuss in greater detail with like Jetsow rule. Okay, if it is unsymmetric haloalkane, then from where the proton is being abstracted. Suppose if we have two options of beta hydrogen atoms, okay, two different types of beta hydrogen, if it is there, then which is preferred with respect to the other one, which will be the major product. All that we are going to discuss in the upcoming video. Thank you for watching.